Okay, so this is a very good challenge problem. Is there a number smaller than 240 with more than 20 divisors? So we said that 240 is the smallest number with exactly 20 divisors.
Yeah.
Is there a number, sorry, 240 is the smallest positive integer with
Yeah.
exactly 20 divisors. And so is there a number smaller than 240 with more than 20 divisors? So this is actually a pretty interesting question.
Well, we could try 2 times 3 times 5 times 7 times 9. Or no, times 2 times 3 times 5 times 7 times 11.
Okay, what's that going to do for us?
Well, we have 5 buckets and each with 2 numbers in it.
Alright.
So if this is less than 240, this has 32 divisors.
Okay.
If it's less than 240, it should work. Then we can say yes to this question.
Ah, interesting. Okay.
Well, I'll do the 2 times 5 times 21.
It's
Well,
210 times 11.
you can say, yeah, 210 times 11. And 210 times 10 is bigger.
Alright, so 2 times 3 times 5 times 7 times 11 is not smaller than 240. Okay.
So, what else could we try?
More than 20 divisors.
So you tried 2 times 3 times 5 times 7 times 11 because you said this would have,
Mm.
you would have 2 choices for the 2, 2 choices for the 3, 2 choices for the 5. So you would have 2 times 2 times 2 times 2 times 2, 2 to the 5th, 32 divisors with that number. But that number is bigger than,
It's a lot bigger.
We could try just one. Oh, we could try getting 21 divisors, which
Ah.
is 7 times 3. We need to get 7 divisors times 3 divisors.
okay.
Well, that might be a little hard because if we wanted, we could do it like this: 2 to the 7th times 3 cubed, but 2 to the 7th. So 2 to the 7th, what? It's 2 to the 6th times 3 squared. So then you have 7 times 3 divisors here. 2 to the 6th is 64 times 9.
Okay. 64 times 9, is that going to be bigger than 240 or less than
It's going to be
240?
bigger,
Bigger.
than 240.
Okay, why?
Because
60 times 4 is 240.
Okay, 60
Now we're doing
times
64 times 9.
Alright,
and it's actually close to 640.
alright.
So this doesn't work. Let's write this over here. What else could we try? We want to keep the large. If we do anything with large powers, we want to keep it to the 2, since that's the smallest prime.
Okay.
Well,
20.
trying to get 22 divisors is going to result in the same problem.
Okay.
Well, but then it would get the same problem for every number after that. If 22 is the same problem.
We could, well, but what about something like 24 divisors?
24 is an interesting one.
It factors easily.
Okay.
So 6.
It's 2 cubed times 3.
Alright, so it's 8 times 3.
8 divisors, 3 divisors.
Well,
Okay, so what could I make here?
you could do something be 2, something be 2, something be 2, and something be 3.
Ah, alright, so that would be 2, 2, 2, 3. 3.
Well,
So,
we want to keep the 3 to this one.
okay, so what would be the power that would give you the 3?
Well, it would be something squared.
Okay, so what squared might be nice?
or 2 squared.
2 squared times
Times 3 times 5 times 7.
2 squared times 3 times 5 times 7 is starting to look interesting.
Well, it's 30. 5 times 2 is 10. Then times
So
20.
So it's 20 times 21. So that's too big.
yeah.
But there are other ways you might factor 24.
So we could say it's 6 times 4.
6 times 4.
6 divided
Well, 2 to 5 is 3.
this. You could do it this way,
Yeah, you could.
Let's see.
and you wouldn't want to do 24 in 1.
No, you wouldn't. 6 times 4, but this is 32 times 27, so that's too big. But how else could you break apart 24?
Well, we have
Well, we could say it's 12 and 2.
12 and.
Or
Try to break it into 3 numbers.
We have.
well, we could have it 4, 2, and 3.
Okay, so what powers would those give you?
So we have 2 cubed times 3 squared times 5.
Interesting.
So does this equal?
This will. So 40. It's 40 times 9. That's 360.
Okay. Dang.
Can you break it up into anything else? So this is what it is.
Yeah?
Or what about 6? We already did 6 times 4. 12. We already did 12 times 2.
Well, actually we didn't do 12 times 2, but it's too big anyway.
Yeah.
Yeah.
So 20 doesn't seem like 24 will work.
Okay.
Well, yeah. Well, did we could do 6 times 2 times 2.
Alright, so what are you guys beginning to think?
I mean, we're beginning to think that there probably isn't one smaller than 240 with more than 20.
Alright, well let's go up and see on Mathematica, okay?
Okay.
Alright.